So I encourage you to use number line routines, really easy to start. They're great because if we haven't used number lines a lot in our teaching, we will end up getting a better idea also. And so it helps us convey that to our students. So helping them understand this magnitude and relationship, you can put a number line up and put an arrow somewhere between two labeled marks on an otherwise blank number line. You can also put tick marks like I have here. And then students can suggest reasonable values for the mark and give you mathematical reasons for why their mark makes sense. Now, I encourage you to use this with math talk and academic conversation in that they get some independent think time to come up with an idea, and then they get to share with their partner or their group, and then they get to change and reason through it before we start sharing as a class. And that gives me time to go around and listen and see what they do and don't understand. It gives other students a chance to hear the reasoning multiple times, especially English language learners who need to struggle with that vocabulary and the language. They can ask for clarification. Students can suggest alternate strategies. Those students who really love this kind of thing, they want to find other ways to think about it, and they need to consider other ways. So if I asked you to figure out what values went on these number lines, what one would you put for that first piece right there, from 4 to 40? What would go in that space of 4 through 40? So pause the video, give yourself a moment to think about that. Maybe talk about it with some colleagues and decide what you think would go there. Okay, and if you don't want to know the answer, pause the video. So the answer is actually 22. And I will tell you that in my trainings, there is maybe a third to a couple of people who have 22 as their answer. So it's about the fact that we haven't had experience with number lines. And when I'm talking about teachers that teach math that I'm talking about. So first of all, we have to know what the space is between 4 and 40, which brings up the point that using 0 as the beginning all the time when you have number lines is a mistake, because it's then we start generalizing that to everything. So a lot of people will put 20 because it's halfway. But between 4 and 40, we actually have 36. 40 minus 4 is 36. So I have 36 as a sum of what is in between the two. There are 6 sections in between the two. And so you could do it that way, and you could do it other ways also. There's 6 sections in between the two. So 36 divided by 6 is 6. And so each one of those tick marks, a lot of people will put 18 right there where the red arrow is, because they figured that out and they went, okay, there's 3 sections there, so it's 18. But if there's 3 sections, I have to add that 18 to the 4 I'm starting at, and then jump 6 each time. So I could actually put 6 jumps on there, or 3 jumps, sorry, of 6, and you could see 4 plus 6 is 10, plus 6 is 16, plus 6 is 22. So then I encourage you to try the next one and see if you can apply what you learned and found out about your thinking in the first number line and try it on the second number line. So it'll also, hopefully you'll think about how you could adapt this for kindergarten all the way up through high school, the use of these number lines, and see what your kids can do and where they're at. They may be great at algebra, but when it comes to this kind of thing, they may struggle. And that's a really important gap to try to fill in with maybe a quick 5-minute routine at the beginning of class. So go ahead and pause the video and try the next one. So hopefully you were able to use some improved sense making and reasoning after your experience with the first number line. And I always point out through my day of doing these routines with teachers how much they struggle with the first number line activity we do, and then they don't struggle hardly at all with the next one. So if you think about that, applying that with students, when we familiarize them with number lines, it's so powerful that it doesn't take but a few and they start understanding these concepts and being able to apply them. So for this one, the answer should be 4 62/100 because there is a 0.2 difference there. There's 5 spaces. I'm going to have them equally spaced. So each one is going to be worth 4/100. So there are actually 4 spaces, 3 spaces added on to your 4 5/10. And if you add that 4/100 for each jump, you end up at 4 62/100. Okay, so it's not just that this is kind of cool and powerful and I believe in them. We've got students who are required to be using number lines. They need to use them to learn about how numbers and operations, learn about them, how they're related, to reason abstractly about numbers, and to display data. So here's a few standards in 2nd grade and 3rd grade that have to do with number lines. I'll let you look at those. And you can imagine where you're going to go if you go below 2nd grade and where you're going to go if you are above 3rd grade, sorry. And then here are the middle grades requiring number line use. You've got 6th grade and 7th grade here. So we know that in 6th grade, a lot of these standards go through a large change. And you can see a lot of number line pieces there. So when teachers across grade levels can agree on these common uses of representation, such as number lines, students benefit from that coherence of using them from kindergarten all the way through high school. This number line is a huge tool. It moves into graphing in high school, or actually junior high, and more complex graphing systems in high school, and all the way to counting and understanding that there's an equal amount of space between each of our numbers when we count. These kinds of things build upon each other, and number lines are a huge piece of understanding that coherence and building our content knowledge onto those. Here is an example of a CASP question that students might be looking at, or any other kind of math test they may be taking along the way, entry into college, those kinds of things. Look at point P on the number line. Now look at each of the number lines A through E. Is the point on each number line equal to the number shown by P? Choose yes or no. This is a lot more rigor and a lot more difficult than just place a number on a number line. We've got to get that conceptual knowledge to the point that they can apply it to do these types of problems. And if you are in a group, I encourage you to pause and see what you think about that. Have a discussion. Okay, number line variations for upper grades. Display a 0 through 1 number line. Then give students a beginning number and ask how far is it from that number to 1. So how far is it from 42/100 to 1? How far is it from 4/5 to 1? Use number lines with different extremes so they can generalize. We just talked about that. We frequently use numbers that they start with 0 or they start with 1, which gives a false sense that there's nothing before 1. And it also gives a false sense of this number line if we're always starting at 0. So we want to be sure as we move up the grades that 0 is not always at the bottom of that number line. And that we take chunks of the number line. Even in kindergarten, what if the number line starts at 5? What's the next number? And that counting on type of thing. Using double number lines for percent, decimal, and fractions, such as these here. You can see there's one from a computer, and we could consider that kind of like a double number line because you have the decimals on the top and the fractions on the bottom. And then you can actually, students can use that strategy because it helps move their numbers away from each other so that they can read them and communicate clearly. But you can also use just 2 number lines on top of each other lined up and put information on there. And you're going to see a few in a minute that move into ratios and word problem solving also. So a number line card routine is another fun way to do this. You can adapt this for all age groups. This one happens to be decimal, fraction, and percent. Put 10 marks on a number line with extreme 0 and 1. Make decimal, fraction, and or percent cards. So you could do just one type. You could blend 2 of them, or you could do all 3. When I do all 3, I make the decimals one color, the fractions another color, and the percent cards a third color. And that way, when I'm handing them out to students, I can give them 2 of each color. I can give them all the green ones, all the pink ones, or I can mix them in any way. I could just be random. So student pairs get a card to place on the line, and they give reasons why their placement is reasonable. If I'm just starting this kind of thing, I'm just giving them one card. We have to learn how to have academic conversations. We have to learn what number lines, we have to learn the routines and all of that. Because I did that so much in my classroom, I was able to give them multiple cards based on where we were in our learning with this concept. It was very important to me that they saw the relation of decimals, fractions, and percent all at one time, because my book tended to break them up and put them in all different places, which was not coherent for me. Wasn't a coherent way to teach that, so I brought that all together. All students can ask clarifying questions during this time because they're working with a partner or a group, and then discuss it. Do they agree? Why or why not? Should we move it? Should we not? Then you can do a gallery walk where they walk around and look at everybody else's number lines and see if it's matching up with what they thought, and share strategies. And then there's some varieties. You can leave the marks off the number line and just leave it as an open number line if your kids are ready for that. You can use extremes other than 0 and 1 and give them decimal, fraction, and percent that are worth more than that. You can leave the intervals unmarked, or you could mix up the card types like we talked about, give them more cards, or give a set to a group. So those are some variations, lots of variety, and you don't have to use decimal, fraction, and percent. You could use this for other types of numbers. You could maybe do even and odd or something like that also. You could get into more concepts, and it always takes those teachers to start collaborating and come up with all these great ideas. So number lines build relational thinking, and that's really important. We want to use open number lines as much as possible once students grasp the concept that the intervals are equal, that there's this amount of space here, that they feel grounded enough to use it. And then once you have that, take those off. Only leave the extremes, because it opens up this world and this type of thinking that's very creative and very freeing. They don't feel like they need to stay in the lines, kind of like coloring in the lines. Take the lines away and they don't have to worry about that. They can be free to move it. It's a little hard for some students in the very beginning, but once they get it, oh, it's just so much faster and so much easier. So here's a problem from illustrative mathematics where a double line diagram was a strategy to find equivalent ratios. So go ahead and pause and read that problem and see how this double number line could be a strategy that would help students solve this. But if we're not using number lines with them, then this strategy isn't going to pop up to mind, and it's not going to make sense to them when they see it. They're going to wonder why we're putting those together. But if you teach middle school, these are just huge in the middle school problem solving, and it can be really helpful with that understanding those ratios and proportions. So make number lines routine and make the thinking visible. Have students share their thinking and explain what strategies they use to the class or a partner. You walk around listening in for students who use benchmarks, skip counting, or other strategies that you want to reinforce or highlight. And then ask 1 to 3 students to share their strategies while you visually record it for others to see. And of course, you could stop there and just be a really quick, once you get this established, you can do this in like 5 minutes, maybe 7. And then other times you can repeat it with a new number. I want to reinforce these routines, so we're going to do a few of them, or they're learning so much from this. That's what happened to me. They were learning so much from these routines I was doing that I would do those longer and I would do less of the lesson I had planned. So you use your expertise and what works for you and what's working for your students. If you commit to these routines and these best practices, the reason that they're best practices and so recommended is they work, they're effective, and it actually makes your job of teaching so much easier. So I really encourage you to give it a whirl. So here's some variations on number lines. You could do find my secret number. Here in this old resource, they called it Who Am I? I like to call it my secret number. So you provide choices. You sketch a number line and put your extremes, and then you have a spot, the dot on the number line, like marked with a star or something, and they have to give what goes there. You could give them choices, which one of these goes there. So that's, you want it, that scaffolding, make sure they have access to the task. So which of these 3 would make more sense to be where my mark is? You can use really large numbers, really tiny numbers. Think about scientific notation showing them the magnitude of those kinds of things. Or you can just put the mark there and have them ask you questions to narrow down what your secret number is. So lots of variations there. And you can always pause and read theirs also. Close, far, in between is another one. Give students 3 numbers and ask which numbers are closest to each other, or ask them which numbers are farthest from each other, or ask them which number is found in between the other 2. So go ahead and look at these, and you can talk with a partner or just with yourself. Would you use those numbers? What would you ask? What would your students be likely to say? And what could you change these to? What values could you change these to be effective at your grade level in heading off misconceptions, on getting that conceptual understanding of your content? What values could go there? Think of irrational numbers and all kinds of things, and what you could put in here. And then don't forget, make sure you're asking, how do you know, for all of these. They need to be justifying, even if it's just justifying to their partner. And then once you've gone around and listened, if they've all justified pretty well, you could say, okay, who said that was this one and who said it was that one, and give you that, or their fist to 5 of understanding, and just move forward. Because everybody has that, you could then add more difficult numbers because they got that one right off. They've got this, I know I can move on. Or, oh, that was way too difficult, I need to back up a little bit. And that convince us, make sure they're giving reasons. So we have to choose rich tasks that create that space for learning. And I think number lines really help us do that. That we want students to see math as creative and flexible, that there's many ways to look at things and many ways to think about things. We want to open up tasks that allow those multiple entry points and opportunities to make sense. Low floor, high ceiling. Everybody sees the number line, they think of kindergarten and first grade. It's kind of a welcoming piece that doesn't seem like really difficult math, but oh my gosh, you can do so many things with number lines all the way through high school. And everybody can participate in the discussion. Everybody can take a guess and an estimate where that goes, and everybody can consider the evidence and have a conversation and be part of that conversation. And we want to do tasks that capitalize on the visuals because it really anchors that conceptual learning for students.